Hey Joseph, this is Miss Tracy. So I'm responding to your request for help in 65-66. First of all, math is hard. Yes, it is. But that doesn't mean we quit or we give up. You have a B+ in this class, and if you give up now, you're going to regret it. So we're not going to do something easier because what we're doing is not difficult. It's just a little bit more than what we were doing before. And you can do it. It's the same thing if you look at it. You just have another step before you can cross multiply. So let's look. The first one we have, it says to solve for x, and you have 1. Oh, that's not the right pen. I don't want to use that. I'm going to use something you can see. Let me get this color here. All right, so we have 1 3/4 over 2/3. And that is set equal to 5 1/4 over x. What do we do when we have two fractions equal to each other? Because these are both fractions, even though they have fractions inside of them. We cross multiply, always. That is always the step whenever we have two fractions equal to each other. But before we can do that, we've got mixed numbers, and algebra, what? It hates mixed numbers. So we get rid of them first. We always, always, always get rid of mixed numbers when we do algebra. We convert that into something that we can use. So we do that by saying 4 times 1 plus 3. So that's 4 plus 3 is 7. So 7 over 4 in this numerator. 2 over 3 in the denominator. We're going to set that equal to 4 times 5 is 20 plus 1 is 21 over 4. And then that's over x. And we're going to turn x into a fraction by putting it over 1. So now we have a fraction, a fraction, a fraction, a fraction within two fractions. Okay? It's perfectly fine. There's nothing wrong with that. We can solve this. It's not going to be hard. I just made that a little bit thinner so that I could write better. So all we're going to do, we're going to cross multiply. We're going to go this way, and then we're going to go this way. Easy peasy, just like we always do. So let's do this way first. Let's do the blue line. So we have 7 over 4 times x over 1. That's this line. Now let's do this line. 2 over 3 times 21 over 4. All right, so there are some things that I see here. First of all, 7 over 4 times x over 1. This is going to give me 7 over 4 times x. I mean, it really doesn't change it a whole lot, right? But over here, I see some things that I can change. So this 4 in the denominator, that is really, if I cross that out, that becomes 2 times 2. And if I cross this out, 21 is 3 times 7, right? So that allows me to cancel this 2 and this 3. So we see now all I have left on this side is 7 over 2. That's all I got. Because we canceled everything else out. We reduced it. Now you could have multiplied it out, and that would have been fine. You would still have been able to reduce it to 7 over 2. And I'll prove it. So 2 over 3 times 21 over 4, that would be 42 over 12. I can divide this by 6 and get 7, and I can divide this by 6 and get 2. So it would still be reduced to 7 over 2. We just did it here where we didn't have to get to the number and then divide. Okay, so remember your steps for canceling is going to help you a lot. So to get rid of a fraction times a variable, we multiply by the reciprocal fraction. So we just take this fraction, we flip it, but if we multiply it on this side, we have to multiply it on this side. So that allows me to cancel the 7s. This cancels and this cancels. It'd be 28 over 28 would be 1. So x is equal to 4 over 2. And you could cancel the 2's out of here and get 2 over 1. But it's just as easy to do it like this. When it's small numbers, it's not a big deal. So x is equal to 2. So step 1, change mixed numbers to improper fractions. That's your first step, right? That's what we did right here. Second step, number 2, cross multiply. Okay, and that's what we did right there. All right, step number 3. We are going to multiply a fraction times a, hang on, let me rewrite that. Times a variable, and that's x, by the reciprocal, which is a fancy way to say flipped fraction. Right? And that's what we did here. Both sides. Step 4, solve for x. And that's what we did here. Okay? 4 steps. Always 4 steps. Change mixed numbers to improper fractions. That's the step we added this time. Cross multiply. That's the one we've always done. Whenever you have 2 fractions equal to each other, you cross multiply no matter what. Even if what's in here is a fraction, it's okay. The only time we make adjustment is if it's a mixed number, and then we turn it into an improper fraction. Otherwise, you just go across and you go across, and then you reduce, cancel, and then solve. That's all we do. If you end up with a fraction times the x, you flip the fraction and multiply both sides. Cancel if you can. That's how you would do that type of problem. Let's look at the next one. There we go. All right, so we had 3 1/4. And my pen is messing up on me today. So 3 1/4 over p equal, so there's one fraction, 2 1/6 over 3 2/10. Okay, so one thing that I see right away is that I can reduce this little fraction right here. 2 over 10 is going to be the same thing as 1 over 5, right? So why not go ahead and reduce that from the very beginning and have smaller numbers to work with? I always recommend reducing a fraction whenever possible to make the math easier. So let's convert all of these mixed numbers. So this is going to be 4 times 3, that's 12, plus 1, that's 13, over 4. All of that is over p. We're going to turn that into a fraction. Equals 6 times 2 plus 1, that's 12, 13. So 13 over 6. And then 5 times 3 is 15, plus 1, that's 16 over 5. Okay, so that's going to be a whole lot easier to work with now. So now we're going to do the same thing we did before and cross multiply. This time we got a pink line and a green line. So let's do the green line first. So we've got 13 over 4 times 16 over 5 is equal to P over 1 times 13 over 6. So here's what I see. I see that I can divide this 16 by 4, and that becomes a 1, and that becomes a 4. So now I can multiply. So 4 times 13, that's going to be 52, and 1 times 5 is 5. Okay? And then this becomes 13 over 6 P. All right, you following me so far? So now we got to get rid of this fraction. So we multiply by 6 over 13. 13 times 6 is the same as 6 times 13. So whatever that number is, the factors cancel each other out. But we got to do whatever we did over here, we've got to do over here. So we got to multiply by 6 over 13. Okay? So I know that 13 times 4 is 52. So I can take 13 out of here and 13 out of here. This becomes a 1. This becomes a 4. Right? 52 divided by 13 is 4, and 13 divided by 13 is 1. So now I've got 6 times 4 and 1 times 5. So I've got 24 over 5 is equal to P, and that's your answer. That's all you're doing. Cancel when you can. If you don't want to cancel, that's fine. Just remember to reduce when you get to the end. The problem is you'll have really big numbers that you have to take a little time to reduce. If you reduce as you go, canceling numbers that are obvious, it's a lot easier to do. So that's how you do those types of problems. And those are going to prepare you for the triangles. So let's do the triangles. So our problem looked like this. We had these two triangles. I'll try to draw a slightly better triangle. And we had, this had 2 lines here, and this had 1 line here, and 3 lines here, right? Triangle 1, 2, 3, or angle 1, 2, 3. Now the length of this side was 5, the length of this side is 9, and the length of this side is 7. Then we had another triangle, kind of like this one. And let me adjust him because he didn't get drawn correctly. There we go. That's better. So he had, this is the same angle as this one. You can tell by the number of marks on it. This is the same angle as this one because of the number of marks on it. And then this angle is the same as this one because of the number of marks on it. They match up. They're oriented the same way. So this is 4, this is M, and this is P, and we have to find M and P. So in order to do that, let's color code our sides just to make sure we get it right. So I've got pink. I'm going to make this side right here, this side right here, okay? And then I'm going to make this blue and this blue. And then I'm going to make this green and this green. And that just helps me see the sides. So now I'm going to name them. This is A, and this is A. This is B, and this is B. And this is C, and this is C. So now they all have names, right? So that I can give the sides a name instead of calling it angle 1 and angle 2. It's a lot easier. So let's create our chart. So let's call this the first triangle and the second triangle. So we have the first triangle, we'll put that in the numerator, and the second triangle, we'll put that in the denominator. So let's look at our sides. So let's start with side AB. So on the first triangle, AB, which is the pink side, is 5. So we do 5. And then on the second triangle, AB with the pink side is 4. That is equal to side AC, which is the blue side right here, right? Now on the first triangle, AC is 9, so that goes here. The first triangle, AC is 9. The second triangle, AC, is the letter M. We just write it down like it is. And then the last side is BC. On the first triangle, BC is 7. On the second triangle, BC is P. So now we have to find the value of M and P. And now we can't do that if we put these two together. But if we use a fraction that's got 2 numbers in it and only 1 variable here, then we can solve it. So we're going to set that equal to 5 over 4 is equal to 9 over M. And we'll do that again for the P. 5 over 4 is equal to 7 over P. So now we're going to do the same thing that we did before, and we are going to cross multiply. Just like that. Cross multiply. Okay, so 5 times M is 5M, and 4 times 9 is 36. Now we know how to solve this problem because we divide both sides by 5. This cancels. M is equal to 36 over 5. That's the answer. So here we do the same thing. 5 times P is 5P, and 4 times 7, that's 28. Divide both sides by 5. This cancels. P is equal to 28 over 5. That's all you're doing. That is all you're doing. But you've got to make this table up here that has the sides in each fraction, and then the numerator of each fraction is one triangle's measurements, and the denominator is the other triangle's measurements. You've got to do it that way, or you're going to get your numbers all mixed up. You've got to do it in an organized manner so that the measurements are proportioned to each other. All right. So let's see what's the next one. And that was M and Q. That was the next pair of triangles that you are stuck on. Let's look at these triangles. So these are kind of turned sideways like that. Okay, and we have this, and then a third one. This is 8, this is M, and this is 5. So now we have another triangle. Okay, and this is 1, this is 2. And we do these marks just to show the angles equal each other, so we know they're similar triangles. So if they are similar triangles, then we can use the proportion statement. So I'm going to label these again, A, B, C, A, B, C. And I'm going to color code them just because, to me, it helps. So AB is blue, and BC is green, and then AC is pink. Okay, now we know which sides go together. So now we can create our table. So I'm going to call this the first triangle, and I'm going to call this the second triangle. You can call it whatever you want. You can call it big triangle, little triangle, first triangle, second triangle. Just call it something that allows you to keep everything straight, okay? You can call it Bob and Chicken if you wanted to. It doesn't matter. So first triangle, let's put him in the numerator. Second triangle, let's put him and his measurements in the denominator. So I'm going to do side AB, side AC, and side BC. Those are the three sides, AB, AC, BC. All right, that's it. So those are the three sides, and now I'm going to create my fractions. And I'm going to fill in my information. So for the first triangle, triangle F, AB is 8. And on the second triangle, it's 12. For side AC, that's the pink side, first triangle is M, second one is 10. For BC, that's the green side, the first triangle is 5, second triangle is Q. Now I have my proportions set up, so I can set them equal. You always want to use the one that has two numbers in it for your first fraction for each of the ones that are missing a number. So we have M over 10, and then we have 5 over Q. And now we just do the same thing that we've been doing. We cross multiply. So I'm going to make this a little bit smaller, about like that. So we go this way. Uh-oh, it's thinking. It's not wanting to do. Come on, computer. It's taking its own sweet time. I've had some computer issues this week, and it's just taking me a minute. There it goes. And then we'll do this side. Then we'll come over here, we'll do this side, and then we'll do this side, or that way. All right, so let's do the first one. 8 times 10, that's 80. 12 times M, that's 12M. All right, if I divide both sides by 12 to get M all by itself, this would cancel, and I get 80 over 12. Well, I know that 80 is divisible by 4, and 12 is divisible by 4. So 80 divided by 4 is 20, and 12 divided by 4 is 3. And then M is all by itself. All right, I believe that that is correct. Double check my answer key here. Yes, that's right. So now I have 8 times Q, so that's 8Q. 12 times 5 is 60. So if I divide both sides by 8, I get Q is equal to, now I know I can divide 60 by 4, and I can divide 8 by 4. 60 divided by 4 is 15, and 8 divided by 4 is 2. So that would be my answer for Q. So you see how straightforward that is? That's really not a lot of math. That's like 1, 2, 3 steps. Right? Now we had 3 steps for each one. We set up our distribution table, our proportion statements. We cross multiply. We divided. We solved for M. We cross multiply. We divided. We solved for Q. The hardest part, the thing that takes up the most time, is the triangles, like making everything match and drawing out our table, putting everything where it's supposed to go. If you can do that, then you can do all the rest. It's not hard. It just takes a little bit of organization. So work on your organization of your paper, of your problem, and that should help you a lot. So I am not going to do the next one. I want you to do the next one, number 6, where you find X and Y. You can do this. The rest of these problems are cross multiplication. You just have to turn them from improper fractions or from mixed numbers to improper fractions, okay? So that is number 7, number 8, number 9, and then number 10. Okay, number 10 is a shape. And let's do it. We'll do that shape for number 10. So we have got, let me see if I'm calling the right numbers here. Yeah. Number 10 is this weird shape right here. It does this. So the way you've got to look at this shape right here is like this. This is a big triangle or a big rectangle, and then you got a little triangle on top. So here's our measurements: 34, 6, 20, and 16, right? And it says that this is 20 centimeters tall. And we have to find the volume. So volume is equal to area of the base times the height. Height is another word for tall. So we know we're going to multiply this by 20 centimeters because that is the height. So what we need to do now is find the area of the base. So let's see what we can do. We've got a rectangle here. Let me get my highlighter. That is this shape right here. This shape is 34 long and 6 tall. We'll call this area 1. Area 1 is a rectangle, so it's going to be 34 centimeters times 6 centimeters tall. Okay, so we're just going to multiply 6 times 34. That's going to be 6 times 30 is 180. Let's just do it over here. 34. And my computer's thinking, there we go, times 6. That's going to be 24, carry 2. That's going to be 18, 19, 20. So that's 204. So 204 centimeters, once, centimeters twice, so centimeters squared, right? Let's look at area 2. We have this little triangle. So if this is 6, then this is 6. And if the whole thing is 20, then this must be 14, because 14 and 6 equals 20, right? Now, if the whole thing here is 34 and this is 16, we can say 34 minus 16, and that's going to be 18. So this has to be 18 right here, because 18 plus 16 is 34. So the area for area 2 is a triangle. So area 2 is going to have this formula, base times height divided by 2. So we are going to say 14 centimeters times 18 centimeters divided by 2. And that's kind of a lot, so I'm going to put it in the calculator. I think it's 126, but I'm not sure. I have to double check my math. And my calculator is stuck. I'm going to end up having to get a new computer. This one just is taking its own sweet time. Let's open. But you see how you have to look at it. You just can't draw this line straight down, because then we wouldn't know how to solve. We wouldn't know what this line is, right? We wouldn't be able to do that. So let's look at 14 times 18 divided by 2. So 14 times 18 equals, divided by 2, is 126. Okay, so I got it right. Yay! 126 centimeters square. So now that we have area 1 and area 2, we can add them together. So I am just going to move this over a little bit so they line up. Put them right over the top of each other. There we go. That works. So now I'm going to draw the line. Actually, I'm going to get my pen and draw the line. So this would be 0, carry 1. That would be 3. And this would be 3. And this is centimeters squared. All right, so now we have the area of the base because this is the base and this is the total area. So we're going to put this in right here, 330 centimeters square. And now we can just multiply this by 20 centimeters. And when we do that, we get 6,600 centimeters cubed because volume is always cubed because it's 3 dimensions. So you have centimeters twice, centimeters one more time, 2 plus 1 is 3. So this is your answer. That is the volume of that shape. Now the next problem is just another cross multiplication with mixed numbers. And then the next one is going to be, the next couple are going to be word problems. So let's look at those word problems. I think there's a way for us to take what we do in class and record it because we worked all of these problems in class last week. So if I can record that, then I can post it for you and then you can review your work. If that sounds okay, I'm gonna try to do that because we do have students who are out also, as well as our virtual students, and then it would help everybody so we don't have to repeat ourselves constantly with students who aren't able to be there. But that's okay. I don't mind doing it. It would just make it a little bit easier for you guys to not have to ask for it. All right, so number 11 says the ratio of Holsteins to Charolais. So give me a second. I'm going to write this up here. Okay, Joseph, here we go. So here's this next problem. The ratio of Holsteins to Charolais. So those are our two different things that we have here. We got Holsteins and we got Charolais. And those are, I do not know what that just did. It just went away for a second. And now it's stuck. And my computer is just not doing right. Okay, I'm going to have to get that back somehow. Give me just a second. Okay, come on, computer. You can do it. Okay, here we go. Let's see if I can get this back. Actually, you know what? I can make this a little bit easier on myself. I'm just going to take this and I'm going to squish it up a little bit. And we'll do side by side, and that'll help a little bit. Won't have as much room on the page, but maybe it'll be easier. Let me escape that. And let's squish this. There we go. I think that'll work better. All right, so let's look here. So we've got Holsteins and Charolais. Those are two types of cows. So I'm going to do an H for the Holstein and a C for the Charolais. All right, and that's going to be what I have here. That's my table. So then I have the ratio and then I have the number, right? So it says the ratio of Holsteins to Charolais in the valley was 22-3. So it's always in the order it's written. So if Holsteins is first and Charolais is second, then Holsteins is first and Charolais is second. So this would be 22. And it's got to think about it for a second. And this one's going to be 3. Okay, so over here, 22 and 3, right? So this is one of our fractions. for our proportion statement. So it says if there were 3,000 Shirley, so that's the number. So there's 3,000 of the C of the Shirley. So that number goes here, 3,000. Then we've got to find the number of Holsteins here. So this is already set up for us. All we have to do is cross multiply, right? So 22 times 3,000, we're going to go from here to here. That's going to be 66,000. And 3 times H, that's from here to here. Cross multiply. Every time you have two fractions equal to each other, you cross multiply. So it's 3 times H. Now if I divide both sides by 3, then 22,000 is the value of H. And that would go where the H is, which would be right here, the number of Holsteins. So 22,000. If I can get it. Yeah, there we go. One more zero. So then we check it. And those are all correct. All right, so that's what you are doing for the rest of these. Create your table. It's going to be exactly like this one. This one right here, you write this table down exactly the way it is, and you fill in your numbers. And there should only be one number that you have to solve for. So thespians to mathematicians, 7 to 5. Thespians is first, so that's our ratio, 7 and 5. Take those numbers straight out of here. If there were 20 mathematicians, that's the number of mathematicians, is 20. The only thing we have to find is the number of thespians. So we write that up just the way it looks. 7 over 5 is equal to, I'm going to put T for thespians, over 20. And then we cross multiply. 7 times 20 is 140. And 5 times T is 5T. We divide by 5. And we find that 70, no, it's not 70, it's 28. Couldn't do the math very well in my head. So 28 is the number of thespians that we have. So I click right there and I type in 28. And then I check it. And it's right. See how easy that is? You're just using the numbers in exactly the order that they are set up. This is a fraction equal to the second fraction. And you just put that variable wherever the information is that you don't know. Let's do the futons and sofas. So it says futons to sofas. Futons is first, 3 to 2. So the ratio is 3 to 2. All right, it says if there were 15 futons, so the number of futons is 15. How many sofas? So you would set that up like this. Let me clear this page. You would say 3 over 2 is equal, if I can get my pen to work here, it's equal to 15. And I'm going to say S for sofas, right? So S for sofas. So then you would cross multiply. 3 times S is 3S. 2 times 15 is 30. And then you would divide and solve. So I'm going to let you solve the rest of these. I do believe that's a table. And then this one is a little bit like that. You just have to think it through, okay? And I think that's all the questions that you had for me. I will be here. And I'm going to go ahead and do that thing where I think I can record the class screen and see what happens. So just let me know how that works out. I'm going to post it for everybody to see. Probably Friday or Saturday. So don't, hopefully you won't miss out on anything that way. All right, that's all I have. I will see you the next time I see you. Have a great week. I'll talk to you then.